All right, guys, here we go. Ready or not? Welcome back. I'm happy to be back, streaming once again. I wanted to take you through a room that really fascinated me called Boogeyman on Try Hack Me. It's sort of a blue hat, red hat, purple hat, and its theme is DNS data exfil the sneaky way. So, with that, let's dive in. So, basically, imagine your boss is giving you an assignment to retrace the steps of an intrusion. So you're going to get to use all sorts of tools. Wireshark, phishing analysis of emails, a little Python tool called link parse, T-Shark even, which is just a headless version of Wireshark, JQ, a JSON query, kind of like a power grep for JSON. So with that said, let's get this bad boy started. Okay, got to reset the room. Disclaimer, I've done this, and honestly, I did it, and I realized, could I ever explain this? So this is my challenge tonight, to explain all the moving parts here. So here we go, guys. So first of all, you have options like always. You can work completely from their setup, which is great if you don't have any of this set up or don't want to go through the bother. I like personally working from my own system, so it's really personal preferences. But this is what you're given. You're given this artifacts file, and it's got all of these artifacts: an email dump, a Wireshark PCAP NG, and PowerShell JSON, which is a bunch of logs on what happened. So this is what some team gave you, and you're supposed to figure it out. Retrace the steps, and then kind of the red team event is to actually do a proof of concept at the end and mimic exactly what the infiltrator did, which is pretty exciting. Okay, so we have our artifacts, which is a copy of the phishing email called dump.eml. We have PowerLog shells, which is at PowerShell.json, and the Wireshark capture, which is capture.pcapng. Okay. So we have a bunch of questions to answer here. So I took the liberty of downloading everything to my computer, okay? Which you can easily do with Python and wget right from this remote system. So the first thing I'd like to do is take a look at that dump.eml file, okay? And this is the behind the scenes look of what a typical email can look. And we can see the source of the email, okay? Which is interesting here. Take note of the misspelling here, right? Which is a typical phishing trick, right? Just to scramble the letters slightly so that when people are distracted or in a hurry, they will click on malicious links. And that's the genesis of this problem. Is some user in this company clicked on a malicious link, and then it started this whole series of events that we're going to unravel here. And it says, "Hi, Julianne, I hope you're well. Just wanted to drop you a quick note to remind you in respect of document. This number is due for payment on January 20th, 2023. I'd be grateful if you could confirm everything is on track for payment. For additional information, kindly see the attached document, and you may use this code to view the encrypted file." So our password to see this. So it looks pretty legit so far. And then this Arthur Griffin, Collections Officer, B Packaging Inc., which is most likely a vendor, a trusted vendor. Okay, and then this is the encoded invoice.zip file. So again, let's just look at what we've got to work with here. We've got, well, let's open this file. So here it is like they would see it in their inbox, okay, the end user. And a couple things I like to check is does the reply to match what you're expecting? So whether you're on a phone or any app, you can quickly right click on the reply to field and you can see exactly where this sender address came from, as opposed to what they might be spoofing. Okay, so underneath this, we see a slight misspelling. They just transposed these two characters. Okay, very clever. And you can see what the end user is supposed to see, which is B packaging, which is who they're expecting. So that's our first sign of trouble here, right? So, and this is another, it's actually very well done because this is probably very similar to what they would expect in a normal day-to-day invoicing. And it's, of course, sensitive. So they password locked it. And so here's our invoice.zip. And we can type in a password, 2023, and it opens to this invoice file. So let's move that. And we can work with it. And then there's a tool in Python called link parse, which is easily pip installed this way. And I've already taken the liberty to do that. And we can run it right from the terminal on that file. And it's just designed strictly to parse .lnk files, which are Windows shortcuts. Okay. So this is the link that she clicked on. And we can see what this thing is really made of. And so already we start to see some interesting stuff. So remember, a link is a shortcut for Windows, right? And here is the relative path that it really points to, which is telling it to execute PowerShell. And then here is the argument that it's given. So here we go, some encoded, most likely base 64. Let's find out what this decodes to. Okay, so what we have here is really downloading from, again, there's that misspelling. My guess is a malicious server. Now, we still don't know what it's downloading, right? But this is already trouble. Okay, this is the genesis of the bad link. So let's go a little bit deeper. And we can look at that PowerShell. Okay, so it's in JSON. Now, look at that mess. The problem with JSON is it's really hard without special tooling to do anything or grep. So let me just demo. If I just wanted, say, pull out SID, it doesn't do anything because it's all tied together. But let me introduce you to JSON query, JQ. Now that's just beautiful, right? Full color, everything is like a dictionary, key value. And then you can start to sort on these different fields with what they call a dot notation. So just give you an idea of what that looks like. So if we choose something like script block text, okay. Now it still looks like, what am I going to do with that? But that's just one example of how you can just pull data. And already you can see, okay, we're on the right track here because we're starting to see these PowerShell commands that were executed on the server. So what I like to do for a quick and dirty is I'll just send it right back to bash and do a sort unique. And I can get a really quick, it may not be in quite chronological order, but it gives me the gist. And honestly, this is what I did the first time through this, and I could just look at the commands executed. But I do want to show you, when you do get more versed with the syntax, and just like grep and all these other things, it does have its own language, right? This is a way you can basically turn it into an array and have it sort first by chronological order, which is timestamp, and then the script block text. And the script block text in PowerShell logs are where all the commands are stored. So now we have everything nice and in chronological order. So if we walk through this a little bit, you should recognize this first command. Remember, this is our starting point from our malicious LNK. So that's exactly what happened here. First thing that happened on the server. And then unpacking this a little bit, it's a little obfuscated PowerShell, but basically it's an infinite loop, while true, to do post requests to this server. Obviously, it's a malicious server. There's that funny spelling again. And it's doing post requests. Okay, so we're not quite sure what it's doing, but it's also pausing, kind of like in stealth mode, every 0.8 of a second. So that's kind of interesting. We're not quite sure what it's doing yet, but we're getting an inkling of what's going on here. Now, they're clearly on the server. They're doing some who am I? They're exploring. And obviously they're on this user's account, right? One they fished. And then here's the first evidence of some malicious activity. Seatbelt. If you don't recognize seatbelt, it's a security tool used by a lot of white hats to do system testing, enumeration. You know, it's a good guy tool, but obviously in the wrong hands, it can also be used for nefarious purposes. And what's interesting is something stops this command. We're not sure what exactly, but if we look a little bit further, he's got to do it a different way. So he downloads it again from his malicious file, folder, server, as changes the name to sb.exe. So, hey, good guy, good going, defenders. Maybe you have this on a ban list, or maybe Windows Defender caught it, because that's very recognizable and banned in most environments. But unfortunately, he just changed the name, and he's back with the tool on board now. And now you can see he's using it to enumerate the system. So what does he do next? It looks like he lands upon a target file. So does anyone recognize what that is? KDBX, it's a KeyPass database. So that is a password vault. So clearly this guy knows, or this person knows what they're doing, knows what they're after. Very targeted. And so that's definitely a crown jewel here. He goes further, a little bit deeper. He's looking for something else. And he downloads another tool, sq3.exe, which is SQLite. So that's a database command line tool. So clearly he expects a database to be here. And sure enough, he goes a little bit further. He's in Microsoft sticky notes now. And then this is what he does. He opens this plum.sqlite tool database, and he runs this command. Okay, this is SQLite for select everything from table note and give me the first 100 records. So he must know something about where this business stores sensitive data, maybe passwords. We're not sure, but the fact that it's very surgical. Like, does this person know this company, where to look exactly? Because it's very targeted. And then the next series of events is the most interesting part to me, because this is how he's going to basically carve up this file so it stays under the radar, and bit by bit in data chunks, he's going to exfil it out to his server. So, and it's all done with PowerShell. It's very clever. So his destination, this is his rogue server. There's his target file, that KeyPass file. And he is converting everything right here from binary to hex for each object to string. X2 is a hexadecimal data format that's used commonly to transport hex character strings over the internet. And then here is the bread and butter of this entire operation. He's splitting this file that's all one big hex string into 50 character long chunks, running it through this for loop, and then he uses NS lookup. Okay, so NS lookup is a DNS tool, right? And he's just querying, and he's concatenating this data, this 50 character chunk. So he's just basically prepending a name and then to his destination. And what this does on the other end is, see if I could just show you real quick. So I could just do anything here. Okay. Rogue.com. And then just because we know that one's, whoops, and it might help to enclose the quote, and it might help to complete the command. Now, notice it errors out, and it really doesn't matter. So what's happening here is his rogue server is just logging every one of these error messages. And what's important here is he's capturing this extra data. Now, maybe something you don't know about namespaces in this domain server naming convention. There are 63, somewhere between 60 and 63 additional characters that can be placed in each one of these. We're used to www.google.com or something. We're using just very simple, human readable, easy to remember, but you can actually put a lot more data. And that's what they're doing. They're just smuggling it 50 characters at a time. First converting from binary to hex, and then on the other side, they collect it and then convert it back and reconstruct the file. So it's pretty sneaky. And of course, the reason they do this is because if you try to smuggle a file, imagine a credit card company with 100 million records, that would be super noisy. It would instantly be stopped because it's not normal to send a file that big over DNS, right? In any network. So this is just background noise, It's just such a small request. It just doesn't even show up on the radar. So what else do we need to look at here? So what we really should do is look at some packets. Capture. Because our next step is to reconstruct all this. Now we know that he went after the first 100 records in that SQLite database. So we have to find out what he found. And it's all in these packets. There's like 48,000 packets, which is crazy. But with a little filtering, we can drill down to see what they were up to. So filtering down on that SQ3 command so we can follow the streams. Okay, this is where he downloaded. And okay, this is where he's running against that sticky notes. And this is the actual command, if you remember, where he ran and grabbed those 100 records. So now, remember, he's running a post request every 0.8 of a second. So now it's starting to make sense to where he sends these GET requests and then a post request comes in 0.8 of a second to presumably sweep this data onto his rogue server. So we want to find a post request that comes almost right after. Okay, so if we look at this and we go down here, this is where the data is actually encoded in decimal. Now it says truncated, which means it had to get sliced to fit the MTU, right? It's sort of like driving a truck over a bridge that's too low. You know, you would destroy your truck, and in this case, you would corrupt your file. So they truncate it, which means simply that they'll just put the rest of it, they'll split it up and put the rest of it in the next packet. So what we can do to grab it all is to follow that stream. And now we can get the entire conversation. So now what we can do, select all this and send it to our special tool, CyberChef. Look at that. It already recognizes it. And what do we have here? This was the data. This was the 100 records. So it's a master password. And if you know anything about KeePass, they have that one master password that unlocks the entire database or vault. And so now there's a password in here somewhere, right? So it took me a moment to look at this, but I look at sort of this, it almost, it's like a parameter with a bunch of dashes. You got the master password, string, carriage return, another sequence of these, and then what comes after? A space, and this. And then the pipe, if you know anything about SQL tables, is that's how they delineate data in a table, column in columns. So that is most likely our fancy master password. So we're going to collect that. And then the other thing that we need to find in this is the actual data exfil of the password vault. So what does that look like? So we know he used DNS. So if we just simply do a filter on DNS and just scroll down here, we start to see evidence of some strange looking queries here. So let's drill down. And what do we have here? This is what they're doing. This is 50 characters long. And see what we talked about earlier, how they were concatenating the hexadecimal string onto the rest of this domain name. Okay, and then sending it, right, to the destination, that rogue server. So what we need to do if we want to attempt to reassemble this is collect every single one of these, okay, because right now it's not very organized. So there's a way to do that, and the syntax for Wireshark is just like anything else. There's a learning curve. What we're looking for here is domain DNS, domain name system, queries, and then the actual name, because we want to filter on this particular information. So they actually have a built-in filter. In fact, I've got this already saved. This is what the syntax looks like. dns.query.name matches, because we're matching on the string. And all I'm doing is I'm matching on this section here, because I know it's going to be unique. And then I use some ampersand, double ampersand logic, which is simply and. It's like and or logic. And then the other filter is IP.destination host is what it stands for. And because we're looking for just packets that went here, as opposed to any of these other. So that should give us everything that was transferred. And it does. And see what it does is even when that last little segment gets captured and prepended to this as well. So now we can grab this. I use the shift key, go up here, copy it as plain text. And we can just dump this to a file. Call this packets. Okay, so we have this packets now. Okay, so now our next mission is to get just the hex. Okay, so we can use a little bit of grepping to do that. So I'm going to cut this. I'm actually going to cut. Delimiter will be that capital A, because now it's just split into two fields, right? The A is the delimiter. So field 2, which will pick up the back end of that. And sorry, I need the dash at the end, which brings it all the way to the end of the line. So now we've got something very close to what we want, but we still have a little bit more work to do here. Now we're going to delineate on those dots. Okay, and we just want the first field. Now that's looking really good. We have this stray header field called NO, and so that's going to be like bowling. It's just going to knock the last pin into the gutter, right? So grep, and the V will say everything but no. And now we should have a clean file. Okay, so let's save this into something called packets.hex. Okay, sanity check. Okay, so we're getting closer. We can't run this file because it's in hex string. So the next thing we got to do is we have to convert it. And this is where we can use Python. So we'll do a short script. Okay, we'll use the binASCII library, which does the conversions for us. And then we'll open our input file, which is going to be that packets. Okay, that we stuffed all those packets, sorry, the hexadecimal in. And that's going to be a read. And of course, and we got to call it something. And then at the same time, we will open our target file, which we can call it whatever. I'm going to give it that extension because it is our password vault. And in this case, now we're writing bytes. Okay. Okay, now we just have to clean up the data a little bit. So we're just going to go line by line, and I'm going to clean up the data by running strip. Just take care of any white space, and we'll call a variable binary data. And then this is where we call to ASCII. And we'll use the unhexlify. Let's type this right. Okay, so this is doing our conversion back to binary. And then the final step is to write to that file. Okay, and we're going to write our bin data to that file. Okay, so let's see if my syntax is solid. Okay, that looked good. There's our loot KDBX. So sanity check. I like the looks of this. So when you run the file command and it is able to read the metadata as a binary and it calls it what we expect, which is the KeyPass password, I think we're cooking with wood here. So, but the final test would be to actually check it out in a vault. So KeyPass, if you've got Windows, there's a number of KeyPass compatible. I've got one handy called AuthPass. And let's see, we can load this thing. So click it. Okay, that's a good sign. It wants a password. Okay, make sure that went through. Wants my biometric. Okay, it opened. So there's that projected data from before. And what do we have here? It's a company credit card from Quick Logistics. Time to go shopping, right? So you can imagine if this were some huge file of customer data, it would just be a huge, that's be a critical finding to say the least. So I hope that made some sense. It really blew me away the first time because I just can't imagine you be able to take a file, chop it up on the one end, send it through the DNS pipe on the other, and then reconstruct it and actually have a working file on the other end. So as you can see, it is more than possible. This does happen to this day in the real world, even more sophisticated methods. But again, I hope you guys were as impressed as I was on the methodology and learned some of the, at least an intro of how some of these tools work together. And happy hacking. Thank you.